So, ladies and gentlemen, on tomorrow's quiz, we're going to have a lot of different sections on tomorrow's quiz. A couple of questions on each section. So, the first one is being able to change from a rational exponent to a radical, or a radical to a rational exponent. So, if I tell you something like the third root of, actually, let me change this. Let's say the third root of 7, and I tell you to change that to a rational exponent, that'll be 7 to the power of 1/3. It's not 7 times 1/3, but it's 7 to the power of 1/3. Likewise, if I give you the rational exponent, let's say 2 to the 1/4 power, well, that would be the fourth root of 2, okay? So that's the first section. It's really just rearranging. The third root is the 1/3 power. The square root is the 1/2 power. The fourth root is the 1/4 power. The fifth root is the 1/5 power. So that first section, I think, is pretty easy. Okay. Let me erase this and move on to the next section. The next section is going to be simplifying radicals. Now that's pretty entertaining. If you have the square root of a perfect square number, that's a perfect answer, right? The square root of 16 is 4. But what if you don't have the square root of 16? What if you have the square root of 18? 18 is not a perfect square number. If you did it on a calculator, it'll give you a crazy decimal. But what we want to do is be able to rewrite our number with multiplication so we could get a perfect square number. Now let me tell you this, guys. Our calculators actually do this for us. That's why if you don't show your work, I'm not going to give you credit. Okay? So you actually need to show me that the square root of 18 breaks down to 9 times 2. So you need to show that work right there. And then the square root of 9 is 3. And the square root of 2 is obviously the square root of 2. So you leave that, and that's your final answer. Okay? And let's do another one of those. The square root of 32, for example. Yeah, you could think of it. I could break that down to 4 times 8. But don't do 4 times 8 yet. Think of a higher perfect square number. What's the next perfect square number after 4? I mean 9, but 9 times something give you 32? No. The next one will be 16. 16 times something give you 32? Yes. So use the highest perfect square number. 16 times 2 gives you 32. When you split it, you'll have 4 square root of 2. Okay? Not only that, it does get a little more entertaining. Sometimes you might have a number out in front. So like let's say you had the, let's say 3 square root of 8. The square root of 8, you could break that down to what? 4 times 2. Split the root. Don't forget about the 3 that's in front. So it's really saying 3 times the square root of 4 times the square root of 2. Now we know that the square root of 4 is what? So you really have 3 times 2 times the square root of 2. So that's really going to be 6 square root of 2. So that could also happen on tomorrow's quiz. I think that's pretty easy if you've been practicing. We had a whole worksheet on simplifying radicals. Make sure you study that worksheet so you can do well on this section. I think one more thing to go over, especially on this section, is if you have a radical in the denominator, you want to get rid of it. So like let's say you had 2 over the square root of 3. That's pretty basic, pretty easy to do. If you wanted to get rid of that square root of 3 on the bottom, what would we do? Multiply both top and bottom by what? By that same square root value. Okay, so that will give you up on top 2 square root of 3. Just write it together. And on the bottom, the square root of 3 times the square root of 3 is the square root of 9, which takes you back to 3 without a square root. This would be your final simplified form without a radical in the denominator. So we have section 1, changing from a radical to a rational exponent. Changing a rational exponent to a radical. Section 2, which is simplifying square roots. And this was simplifying square roots right here. We also have the next section, which is classifying polynomials and knowing all about the vocabulary in section 8.1. So let's say I wrote this up here. 8x squared minus 3x to the 4th plus 9. Is this in standard form? No. It's not in standard form, okay? Standard form is from highest exponent down to smallest, and if there's a number without a variable, that would be a constant at the very end. So one thing I might ask you on tomorrow's quiz is to rewrite it in standard form. That'll be negative 3x to the fourth. That's your highest exponent. Then the next one's going to be a positive 8x squared, and the last one's going to be a plus 9. Notice that this minus sign in front of the 3x to the fourth, it's part of the 3x to the fourth. So when you move it to the front, it has to be right there. The minus sign has to be right there. Okay. So now it's in standard form, and now I could ask you to give me, let's say, the leading coefficient. What's the leading coefficient? Now, even if I asked you, what's the leading coefficient of this one? You can't say 8 because it's not in order yet. So what's the leading coefficient of this guy? Negative 3. So the leading coefficient is negative 3. What if I asked you for the constant? That's 9. That's right. Piece of cake. What if I asked you, what is the coefficient of x squared? What is the coefficient of x squared? 8 is the coefficient of x squared. Makes total sense. The coefficient of x to the fourth is the leading coefficient because it's out in front. The coefficient of x squared is 8 because it's in front of x squared. So all those vocab words are going to pop up. In addition to the vocab words, we're also going to have to classify, giving them a first and last name. So looking at this, what would be the first and last name if I were to ask you to classify it? First name is based on degree. In this case, the highest power is 4, so that would be quartic. Yes. Trinomial. So we need to be able to classify polynomials also. And that's still from section 8.1. And in addition to all these vocab words, and in addition to rewriting it in standard form and identifying the leading coefficient, the degree, and the constant, in addition to all that stuff, we're actually going to be adding polynomials with polynomials and subtracting polynomials with polynomials. So, let me make some space here. Let's say I had x to the second minus 3 minus, let's say, 2x plus 8. Let's keep it simple. A binomial minus a binomial. The first thing to do is to recognize that there's a minus sign between them. Now, if there were a plus sign, I could just start combining like terms. But if there's a minus sign, you know that that minus sign, if you distribute it, it will change those signs. So you're going to end up with a negative 2x and a negative 8. And the first parenthesis, there's nothing in front to distribute. So you don't distribute anything. You just bring down the values without the parenthesis. So you really have x squared minus 3 minus 2x minus 8. Is there anything else to do here? Let's combine whatever we could combine. What could we combine? Could I combine the x squared with the x? Heck no. Could I combine, what could I combine? The negative 3 and the negative 8. Notice that I'm circling including the sign that's in front, because that's like telling me whether I have $3 or owe $3, whether I have 8 or owe 8. So if I owe 3 and I owe 8, I'm going to owe a lot. I'm going to owe a total of 11. And then I cannot combine the x squared with the negative 2x. So the only thing to do is to put them in order and put your answer in standard form. You want your highest exponent term first, x squared, and then you have your minus 2x right in between, and that's your answer. So I'll probably ask you to find the answer, and then in addition to that, classify it. What would this one be called? Close? Quadratic. Quadratic trinomial, right? The power of 1 would be, if it were just an x, that would be linear. Power of 2 is quadratic. Power of 3 is cubic. Power of 4 is quartic. Power of 5 is quintic. And obviously the number of terms is easy. 1 term is monomial, 2 terms binomial, 3 terms trinomial, 4 or more polynomial. And the final part of our quiz will come from this worksheet that I just handed out, section 8.2. We already added and subtracted polynomials. Now we're going to be multiplying a polynomial by a monomial. This is pretty easy to do. A monomial is one term. Polynomial, many terms. So we're going to be distributing one term into a parenthesis with many terms in it. Okay? So number 1's too easy. All those are too easy. Let me jump to number 5. Why not? Number 5. So number 5 on the worksheet, we're going to distribute negative 3n times n squared. Let me ask you this. What is the coefficient of n squared right now? What number is in front of n squared? A 1. So it's really like saying negative 3 times 1, that's negative 3, and then n times n squared. What's n times n squared? N to the third. Okay, so that's your first term. And now go negative 3 times positive 2n. We'll do the coefficients first. What's negative 3 times positive 2? Negative 6. So I want to put a minus 6. And then how about n times n? N squared. You see? It's easy. Let's go for something more challenging. Something like number 12. We're going to take this negative 3n squared and multiply it here. What is the coefficient negative 3 times the coefficient negative 2? That is positive 6, right? And how about n squared times n squared? N to the fourth. You simply add them when you're multiplying, right? You add the exponents. And then you go negative 3n squared times positive 3n. How about the coefficient negative 3 in the front times the positive 3 that's in the middle right there? Negative 9. And how about n squared times n? N to the third. And last but not least, how about negative 3n squared times positive 4? The coefficient negative 3 times the constant 4? Negative 12. And then the n squared, you're not going to multiply it with any other n, so you just put it on there, n squared. And that's it. I mean, of course, I could always ask you to classify your answer. If I asked you to classify this answer, the degree is 4, so that'd be a quartic. There's 3 terms, so that'd be trinomial, quartic trinomial, if I asked you for that. So this next portion of the homework's even more fun because it has distributive property and combining like terms. I love it. Okay, so let's jump to something that's a little more challenging, like number 19. So we really have multiplication, subtraction, and multiplication, right? So let's distribute first, multiply first, and then worry about combining like terms. Technically, you're supposed to look at inside the parentheses and see if you could combine anything, and you can't because you can't take away b's and numbers. Right here, b squared minus 7b minus 4, inside the parentheses you can't do anything either. So then you jump to distribution. 4b times negative 5b. What do we get? Negative 20b squared. And then 4b times negative 3. Notice that the minus 3, I'm calling it a negative 3. It's easier. What's 4 times negative 3? Negative 12, but I'm putting it as a minus 12. And of course with the b on there. Because the b right here, there was no b to multiply it by, so you just bring down the b in front. Or at the back, sorry. And now we're going to distribute the negative 2. Notice that I'm calling it a negative 2 instead of a minus 2. I want to include the negative sign. That way we don't have to worry about it later. Negative 2 times b squared, that'll give me a negative 2b squared. And then negative 2 times negative 7b, that'll be a positive what? 14b. And last but not least, negative 2 times negative 4, what do we get? Positive 8. Now we have this huge polynomial that could be simplified because there's many terms that are alike that we could combine. Let's start by doing the highest exponent term, the power of 2. So negative 20b squared minus 2b squared, that'll give me a negative 22b squared. Notice right here, we're not messing with exponents. You're just combining. It's like saying you owe $20 if the b squared were dollars, and you owe $2 more. It's going to be owing $22. And then let's combine the negative 12b with the positive 14b. That's going to be a positive 2b. And last but not least, the 8 over here, there's nothing to combine it with, so you're just going to bring that down. And you're going to put plus 8 at the very end. Ladies and gentlemen, we're done distributing and combining. We'll pick up on the next video.